Electrostatic potential store. This is the energy store associated with the charge on different objects. Now for GCSEs you do not need to know the equation for this. However, it may be useful to understand it for when you move on to static electricity. It will also be useful if you want to move on to A-level physics. So the first thing we must understand is that atoms are made of protons, neutrons and electrons. And protons have a positive charge, neutrons are neutral, and electrons are negatively charged. Now electrons orbit the nucleus of the atom. The nucleus is where the protons are. And so they feel a force of attraction to the nucleus. This is what keeps them in orbit. However, it is possible to strip them off the atom, leaving behind more protons than electrons. This will cause the material to become positively charged, and that is what's happening in the Van de Graaff generator on the screen. What we have is a rubber belt being brushed past a comb, and that rubber belt is removing electrons from that comb, leaving behind more protons in the comb and the globe. So the globe becomes positively charged, meanwhile the wand becomes negatively charged because it is gaining electrons. Now, when you notice a spark move from the wand to the globe, this is because they have energy in their kinetic store. The electrons have energy in their kinetic store. And the question is, where did that energy come from? Well, it came from the fact that the electrons in the wand are attracted to the protons in the globe. So therefore, there is energy in the electrostatic potential store. So we'll look at the equation now. We have EE, which is energy electrostatic, is equal to KE, which is Coulomb's constant, little q, big Q, over R, where little q is the charge on one of the objects, big Q is the charge on the other object, and R is the distance between them. So let's look at how the energy depends on these quantities. First of all, if we have two systems, system 1 and system 2, system 2, in this case, has a greater charge on both little q and big Q, which means it will also have a greater energy in the electrostatic potential store than system 1. The greater the charge, the greater the energy in the electrostatic potential store. However, it gets more complicated than that because we're dealing with two types of charge, positive and negative. So let's look at what happens when we place two positive charges next to one another. In this case, they will accelerate away from one another. Now this means that there is a lot of energy in the electrostatic potential store. We know this because they accelerate away from each other, gaining energy in their kinetic store. Where did that energy come from? It must have come from the electrostatic potential store. So two objects close together, which are both positively charged, have more energy in the electrostatic potential store than two objects that are far away from each other. The same is true for negatively charged. If you've got two negatively charged objects next to one another, they have more energy in the electrostatic potential store than two objects far away from one another. However, if we have opposite charges, in this case we have system 1, the positive charge and the negative charge are close together, and system 2, where the positive charge and the negative charge are far away, system 2 has more energy in the electrostatic potential store. This is because when they're far away from each other and they feel a force of attraction, as they're attracted to one another, they will accelerate. They will get faster, which means they get more and more energy in the kinetic store, which means when you've got opposite charges and they're far away from each other, there is more energy in the electrostatic potential store. So in this case, because they're opposite charges, system 2 has more energy in the electrostatic potential store than system 1.